All right, we're gonna really kick off now. I'm Karthik. That's an old picture of mine back when I had some hair. I have been doing a bunch of Go stuff over the last couple of years, and at Stack Engine, I also do a lot of Docker stuff. So Docker and Go is kind of like my field of interest and expertise right now. Quick show of hands, like how many folks in the audience write Go code right now? Sweet. That means I can't BS. And how many folks are like dabbling in Go projects, so kind of want to get involved with Go, things like that? All right, cool. So that's good to know. It's good to get a quick understanding of the audience before we kick off. The folks who already write a lot of Go, if there are questions or whatever, I'll kind of look to you guys to add more input to make things a little bit more lively. Quick history of Go. It's open source. It's almost 6 years old. Kicked off in November 10th of like 6 years ago, so it's close to 6. The story is that they were looking at a lot of C++ code, and they were like, well, this is really, really hairy. Is this the best choices that the founders of C++ have made to like create this code or the code base, and how can we do it better? So that's kind of where like the brains or the wheels started turning in order to actually get to a Go version. Currently, we're on Go 1.5, and I looked up to get a count of companies other than Google. There's an article about over 200 companies that actually use Go in production today, or have been messing with it. So that's a pretty good number. And then at the last couple of GopherCons, there've been like about 1,200 people who've gone to the conference, which is pretty huge. I think the biggest conferences that I've been to is probably like Velocity, which is 5,000-6,000 people, but or I don't know if it's that big, but 1,200, like anything over like 800, it's like a pretty huge conference. A lot of people, if you like, for those folks who don't use Go already, if you read about it, they're like, this is really good for like writing web apps. It's like super performant. It's great for like doing DevOpsy kind of things, config management, stuff like that. That's where Go kind of plays like a good niche. And then, the more stuff you read about Go, you start seeing like crazy things about, it's like, well, like why PHP people should learn Golang. And then I went from Python to Go, and it's like changed my life. And then you read stuff like 30 servers to 2 servers with Go, blah, blah, blah. So, and then there's like, it's the next big language and whatnot. So you start like wondering if this is all FUD. So this is a security conference that we're at. So we kind of wonder, or the question that we should be asking ourselves is like, is it secure? What about ownage? Does somebody who on the Go side actually care about this stuff? So I looked up some stats, but before that, sometimes in some languages, like you read a bunch of stuff and you're like, well, you might publish the code in GitHub. It's all like open source, but you'll have like 1,000 issues. Some of them might be security issues. Some of them might just be like feature language issues. But like nobody really cares. So on the security side, from a statistics perspective, I wanted to see with really good languages, you typically have like a security policy. Like, hey, I found a vulnerability. Like, is there a way I can report it? Can I contact somebody about it? So nice thing is that there's actually you can go, the link is up there, but you can go to that place. There's an email address that you can, reach out to, or there's also like a whole like chain of command. So if you contact Andrew, don't get a response, you can contact Adam, or go to the mailing group, which is kind of nice. It gives you a little bit more faith in the language when you find something severe, or if you find something severe. Also, from a vulnerability perspective, list, there's not that much that's come up in the last couple of years, which is good. Not to say that there won't be any, but there hasn't been a lot of things been found, which is kind of nice. So to jump back, if you're a person trying to evaluate Go and think about it from that perspective, it's not, you look at it, you look at some of the stats, and you're like, okay, well maybe I will try it out. So the rest of the talk, I'm going to kind of focus on like different features of Go, things that you would want to like think about or considerations from a security perspective, and just features from the language that about why Go is like a good thing to know. First and foremost, it's strongly typed. So unlike some other languages that are not strongly typed, you can't just like randomly on fly like change an object from one object to another. So there are pointers, but there's no like pointer arithmetic, so you can't randomly change an int to a string from a memory perspective. It's also memory managed, so you have like a garbage collector, very similar to Java. So you have the garbage collector that comes by and then manages your memory in a little bit more efficient manner. One thing I really like is from an array perspective, and in Java, if you have like an index out of bounds or array index out of bounds exception, that's just an exception that gets caught in your code. In Go, it's like a hard panic. So if you do end up like with those errors, you'll end up like with a panic. Your application will stop. And so that's something that they take a lot more seriously. Well, not seriously, but the philosophy on those kind of things is a little bit different from other languages where it's just like, well, your application might have failed, and if you just kind of handle the error in your one segment of code, your application still ends up performing, but you don't actually know whether something went wrong or not at that specific instance. Once again, no pointer arithmetic, so you can't create buffer overflows, which is awesome. Quick set of tools that are really cool is one of them is Go FMT, and for the folks that use Go, like what do y'all think about FMT?
It's like Pep 8, but it does it for me.
It's like Pep 8, but does it for you. Nice. It's basically like a source code formatter. So whenever you save your code, Vim, I personally use Sublime Text for all my coding stuff for Go. So I use Go Sublime, and whenever I save my code, it also formats it for me. So one of the nice things about it is I don't have to kind of like think about how to format my code, or like go to like my company or my boss or something like that and ask him, hey, do we have like rules for formatting? Do I have to use tabs or spaces and that kind of stuff? And one of the nicer things about it is that it's very opinionated, so you can actually tweak it. So if somebody likes, if person A likes spaces versus tabs, they can go change that. It's just, it's already set. And one of the motivations for this, and I actually like this motivation a lot, is who here in the room likes code reviews? It's not a trick question. So everybody should like code reviews. It's a good thing. The reason people don't like code reviews is you go there and you're like, well, this code looks okay, but I don't like the way this is formatted. And then you end up with this like philosophical discussion for the whole like hour or how much ever time you have in your code review just talking about the format. So the authors like realized that, and they're like, you know what? We're gonna like create the standard and not let you change anything about it. So you can actually focus on the more important things in the code, whether there are like bugs or things that you can optimize and stuff like that, as opposed to should there be a new line here or no new line. Other stuff, Golang, it's a code linter. And it's kind of simple in the fact that it also just helps you like find random linting issues for your code to be more consistent. One of the reasons I use it a lot is you can kind of tell, like, if you're using underscores versus camel case or spaces or things like that, it'll kind of tell you, hey, you're using this in one place and using this in another. So like it'll help you find like simple things like that. And in one of my gigs, we used to actually use the Golang in our CI pipeline. And that was really cool because you were like linting your code anytime you checked in code. But there were two issues with that. One was like sometimes the lint standards would kind of change on you. So you check in something, you check in like a one-line change, and then you're like, well, wait a minute. The lint is telling me something different because like they've changed like the linting standard on there. So it's kind of like volatile from that perspective. You check in something, your front-end person would check in like JavaScript code, but then all of a sudden there'd be a Go error and you're like, what's going on here? And the other thing is GoVet. I haven't used GoVet that much, but it helps you find like random kind of pieces of code that you don't really want in your code base to begin with, like useless assignments or unreachable code. One thing is really good for is I make this mistake a lot where I'll have like a printf statement and I'll put a %s, but then the value I'm passing to it will actually be different. So it'll have like a %s just sitting there as well. And then I'll like change it to maybe from a printf to like println or something like that, and then that thing will just like look invalid in the logs. So it's good to find things like that. There's a bunch of other tools as well. You can take a look at the link. But the three tools, GoVet, GoLint, and GoFMT are like the three big ones that you kind of want to think about. Also, standard packages. In a lot of languages, there's a lot of like different ways you can import, third-party libraries and things like that. With Go, primarily like in the 2 years I've been working with it, there have been a few, like very few packages that I look for outside of the standard ones. For example, in Ruby, when you're trying to find like a new gem or something like that, you go and like look for a new gem, and you don't really know whether the gem you're looking for is like a great example. So like for me, what I always used to do is I'd go to GitHub, or like I'd do a Google search on like, okay, I need to find like a gem that does like XML parsing, and then I'll find like a list of them, and then I'll be like, well, which ones of these are actually like in active development? Which ones of these have been like being maintained? How many users kind of use that? A lot of those issues kind of go away with Go because you're just using the standard one that's that comes with your with Golang to begin with. Oh yeah, and with that, for cryptography and things like that, there's a really good like crypto package to help you do like cryptography kind of stuff. So you want to use when you're thinking about like creating secure random numbers, or you want to create any kind of random numbers, crypto.Random is the thing that you're going to want to be looking for, as opposed to math.random. Behind the scenes, that uses like dev.util.Random by default on Linux. So that's kind of like one of the best practices for that. If you guys want to like read more about crypto and that kind of stuff, you can take a look at the Go Crypto, the link down there. Kyle has posted like a bunch of stuff that is really good, from like what kind of packages you want to use and kind of where you want to take. Like it's a lot more in-depth in terms of cryptography. The other thing that's really handy, and this is not necessarily a security feature, but more of like it's a nicety, is when you are, so let's say you work at a company and you're like trying to distribute your code to someone else. All you end up building is just one single binary that, that's the thing that you're distributing. It's all statically linked, so everything that you need is in the binary. It might be kind of big because it encompasses like literally all of the code, but you know that as soon as you get that, that's going to install on a client's machine or something like that. There's not going to be something wrong where you have to like look for dependencies that sit on the operating system and things like that. So it helps with, it reduces like installation burden a lot. Also, so single binary and your application. So your application ends up having a ton of dependencies to begin with. So how is that problem kind of solved? And different languages kind of do different things. But in the end, you end up having some kind of package management strategy. So in Go, there's a bunch of ways you can do this, but you end up using package management. And the two big things, does actually everyone know what package management is and how it's implemented in like different languages, like in Java or C and anything else? Show of hands. Cool. Okay, so for the most part, package management is where you end up like building things alongside of your code. So all your dependencies kind of sit alongside. Reasons you want to do that is, so let's take Ruby for example. When you're doing like a Ruby install, like a gem install or something like that, and your application depends on like one version of the gem, and you might and your application lives inside of GitHub, and you have like multiple people kind of developing the same application, and let's say you change, you realize, oh, there's a new version of the gem that you're using, so you upgrade it, but then you check in your code, but then it does not work on your teammate's computer because they have an older version of the gem or something like that. So package management and dependencies, or package management helps you a lot with that because it ends up building all your stuff alongside, and your builds become a lot easily reproducible as well. So on the Go side, there's I think there at one time there used to be a lot, but then over time they've kind of like standardized on a few. GoDep is the one that we've been using. Or I haven't actually used another. There's a few, but typically GoDep is the most popular one. And the reason that most folks use that, or most folks like to use that, is because all of your code ends up being renderized. So you have like a GoDep, like in your application or in your GitHub code, you have a GoDep folder, and like all of the dependencies end up living underneath that. It's a quick analogy for that would be like Java Ant. So you have in Ant you have all your jars that kind of live alongside your application, but instead of having a jar file, you actually have the source. So if you're trying to debug, something goes wrong in your code, you can try and debug that. You can actually go into the GoDep folder to that specific vendor code and kind of take a look to see what you might want to change, or what might be going wrong in there. Any questions so far? What's up?
Yeah, you mentioned package management for C.
Package management for, well, not necessarily C, but like C++ or C# has like NuGet. Some people kind of use that. I don't know if there's like anything good on the C side. Anyone else have good answers for package management for C in the audience? I don't think there's necessarily good answers for it. Any other questions? All right, so let's continue on. So web application building. This is when I started developing for Go, like our use case was to build out a web app at the first place. And I was like, wait a minute, this is really weird, because in like less than 10 lines of code, this is actually all the code you need to write to build like a simple HTTP server. In here, so if you look at the main function, this responds to like just whatever / you have a handler associated with that, and then this will run on port 8080 that'll respond with hello there or hi there, I love whatever is passed to the actual request or to the actual URL. So that is like all encompassed. You run that, or you compile it, run it, and then you have like a live server up and running that you need. So it ends up making your life a lot simpler. You don't have to like depend on, you take this, run it on a different server or something like that. That by itself is your HTTP server responding with a request or responding to a request that's sent to it. So from a web app perspective, you start there and you end up building out a larger application. So in terms of some of the scenarios for web applications like cross-site scripting, one of the recommendations here is to use Go templates. So Go templates that's a package that you can use. There's an HTML template and there's a text template. With that, if you end up using the HTML templates and you end up taking the template, processing that, and saving that as a HTML file, or responding with an HTML file, it does all the HTML escaping for you. So if you had like cross-site scripting tags in there, it converts that to just HTML friendly kind of tags. One big caveat is so both of these packages have the execute template in there. So from an inheritance perspective, HTML or text template is like the base, and then HTML template kind of extends from that, or not extends, but inherits from that. But you end up in a scenario where, let's say you take off an import. I don't know if I have. So the very top part here is like import whatever. So you're importing, in this case FMT and net HTTP. So for templates, it would be import template slash or HTML slash template. But if you get rid of that and you use FMT to save it, it might save it as text template. The problem with text template is it doesn't actually do any of the escape tagging for you. So the problem you end up with is you can accidentally introduce text templates, and then you have a problem where you've also introduced cross-site scripting in your code. I've done that once on accident because I was like demoing this. I was demoing FMT, and I was like, yeah, check this out. You can like get rid of all this import stuff, and you save it, and it'll like add it back in. I didn't realize it added the wrong thing back in there. So you end up in scenarios like that. The good thing about it is if you know that your code it runs. If you know that your code is like a web code or whatever, you can create a quick test for that. So your CI thing would catch something like that. Does that make sense to folks? All right. The one thing that we use a ton, there's a bunch of other frameworks. Gorilla is not something that comes standard with Go, but it's a toolkit that you can use, and it's a third-party kind of thing. But a lot of folks use that to write web applications. It's not something like huge like a lot of other kind of like toolkits that are out there. So it's not like Ruby on Rails where it's like this large thing where you have to understand like all the different pieces. It's more of like little pieces that you want that'll help you do specific things. So what exactly am I talking about? From a security perspective, like there's actually 3 things that are really good, or maybe 2 things in this case. One of them is secure cookie. So web applications typically end up having a lot of like cookie-based authentication or cookie something, like you end up using cookies in your apps a lot. This provides you a good clean way to do to create secure cookies. When you have your cookie, you have like a key and a value. So a secure cookie basically encodes all of the values for you. So if somebody like in transit, somebody sees those cookies, they can't actually like tell what it is because it's encoded. And you can write code to kind of do all of that yourself, or you can use the Gorilla toolkit to help with that scenario. All of those things are kind of validated with HMAC, which is a good way to do that. And if you want to add encryption, there's also methods that you can use to do that. The other big thing in here is sessions. So it's another simple, like when you have web applications, you might have sessions associated with that. So this gives you a good way to kind of like access, like save off and access like different session kind of variables. And the other interesting thing about it is you have control over your, what's that called? You have control over your authentication and encryption keys. So if you set a session that's valid for a week or a couple of weeks or something like that, you can roll those as you go along. So if somebody hacks your site, and then you end up changing your authentication tokens for it, then you don't necessarily it might be for a week where you have issues, but you can kind of keep rolling that on a continuous basis. So it's a nice function. It's like nice functionality to have where you can kind of automate simple things like that in here. Other stuff that might be interesting is Mux. Mux is great for routing. So does anybody write REST-style services or web services in the audience? Show of hands. Okay, a few. For all of y'all, you might want to check out Gorilla Mux, where you can kind of like say, this is kind of how you want to, build out your REST-style service. So Mux helps you with that. There's also like Gorilla context and WebSockets and things like that that you can look at, but there's nothing. All of those like kind of help you like make your code a lot cleaner and give you like helper methods. All right. So there's one issue with using Gorilla, and I think this happens to. I'm a developer, and this happens to me a lot, where I'll like look at example code, I'm like, okay, this is great, I'm going to use this. So the Gorilla Mux example is a great example. You go to their site, you can kind of like take all the code that you need and paste it, and so it kind of starts off with when you create your your secrets, it says something very secret, but people don't change that. What you want to do is you want to take that and like actually change it to something, that's something very secret, not leave it as is. But if you do a GitHub search, there is like 200 instances, in public GitHub, there's like 200 instances of people have just kind of left it as is in Go code, which is awful. So when you take sample code, it's great to take sample code because it gives you a place to start, but make sure you're actually paying attention to what you're doing. So come on, man. Other stuff that's interesting from a security perspective is there's another library called Secure Middleware. And this helps with, like when you're getting started with an application, you might have something small, and as you grow, you want to like do, XSS or like CSP headers and things like that. Or typically when you write an application, you'll do an HTTP application, and then you're like, well, I want to transpose this to HTTPS. So the secure middleware library kind of guides you through, how to do that. This is a quick code example. So for developer folks on here, you can actually just say, in this case, you can say, what host might be allowed for that code. If you, allow SSL redirects, or if you want to do like browser XSS filtering and things like that, you can use this framework. Either you can use the library just out of box, or use this as a reference example to actually implement this in your own code. Either way. So CSRF and CSRF tokens, another typical thing in web applications. One of the libraries that's useful to check out over here is the NoSurf library. It's just a simple package. I think it's like 200 lines or something like that. But it helps you with, gives you all the code to kind of guide you through how to protect yourself from, cross-site request forgery. And if you look at an example of that, this is kind of, it's kind of a simple example where, in your form, I've kind of cut out a bunch of stuff, but you have your template, and then you just have like a CSRF token that inside of your template, and then in your handler function actually responds to the context token where you generate the NoSurf token, and you put that in your HTML body, and then when you're actually executing this on in your code, like if it's a form post, NoSurf will like look for that token, and if there are issues with it, it'll kind of tell you, hey, it'll either reject the response or it'll kind of guide you through that process. All right, so moving on. Actually, before I move on, any questions so far on the web app kind of stuff? All right, so SQL injection, this Go says that they have like cool new ways to like protect yourself from stuff, but in essence, if you can create a SQL injection in Java, it's like the ways you create SQL injections in Java, it's the same way you end up in Go as well. And that's by this, in the two examples that we have, in the oh no example, we're just concatenating stuff together. So that's the string that creates the SQL. You never want to do that. You always just want to use a parameterized variable, when you pass it to the database. And the reason the first example is not a great example is because your username is coming from, from your form or like from user input. So people can kind of mess around with that and do whatever they want. And if you trust whatever is coming in to begin with, you end up with people doing malicious things. So all in all, some best practices best practices for this are, and this is kind of, I don't think this is Go specific, but when you have a database, you want to kind of and you have a user that's accessing the database, you want to basically limit that to like the minimal set of permissions that you can get to, so people don't, if one database is compromised, like everything's not compromised. So if it's just like a database with 10 tables, that's all you want to give them access to. And if it's a read-only kind of user, add more permissions associated with that. Sanitize inputs before you store them off, regardless of whether you use prepared statements or not, because you don't want it to get to that database layer. If you can cut it off at the web server layer, that's better than letting it through like all of your different facades. Parameterized queries, that's huge, and if that's probably like of all the things in this slide, that's probably the most important one. Always use parameterized queries in any of your code. And if you're like doing a code review or something like that, always just make sure to look for db.exec. If you see a db.exec versus a db.query or something like that, make sure you look at that to see if they're using parameterized queries in there. And the recommendation is just use like prepared statements or queries. And then last but not the least, in your CI cycles, you can run your code against SQL map, or if SQL map is too complicated, just use Gauntlet, which is an open source project that James Wickett in the back is like the core contributor to. Oh, so actually, this is my last slide. And this was kind of a joke slide when I first put it in here. I was like, yeah, like I use Go, and like my friends kind of use Go, so it was like a joke slide that I would kind of end with. But truth be told, a lot of these folks are like really good security folks, and me as a developer, like I understand how to code, or I understand how to code really well and things like that, but I'm not a like master from a security perspective. So it's easy for me to like reach out to folks to ask them questions like, if it's something on like security or cryptography, I'm like, hey Nick, have you seen this before? Is this like a good library? Or James, who's local, I can just be like, ask him on Twitter or something like that. So it ends up like helping you actually code to a better standard. And I feel like in our different communities, like from a developer community, we're like really close. Ops might be really close. DevOps is kind of close. But Austin, we've started to do this thing where we're like rugged development, where we have folks from the security community really wanting to help out folks on the dev side. So it's very, very, very open from that perspective. So if you have questions, you feel free to reach out. Some of the folks on here, you probably already met Matt Tresaro, who talked earlier today, Matt Johansson, James. I don't know if Mike is here. Mike McCabe, he works at Envisium. He and a bunch of other developers there also use, they use Go heavily. And their blog actually has a lot of really good Go tips on like, from a Go security standpoint, so take a look at that. And then Nick, who spoke earlier today as well. The other person on there is Eric Anderson, my CTO, and he's really easy to approach as well. Cool, so there's more resources, but the big ones on here, for the folks who are local, there's a Go meetup in town that happens every month. So check that out. It happens at Humble downtown, so that's a good place to go. You can have spend a couple hours hacking on different Go stuff. But for those kind of who want to get started with Go, take a look at the Go docs. That's a great. It sounds counterintuitive, like coming from I used to do a lot of Java stuff before this, and if you're like, hey, go look at the Java doc to start, it's kind of like a weird place to like think about from that perspective. But the Go docs actually kind of guide you through. They all have examples for how to use them, which makes a big difference in my opinion. Bunch of stuff about like Golang.org also has kind of how to code with Go, and they have this like little web editor which is awesome. You can kind of put your code in there and see it run and things like that, which makes things a lot simpler when you're trying to learn something new. And the other stuff in there as well. So any questions so far? or and the folks in the audience, question for y'all, like are there folks that kind of want to know, like for the folks that don't use Go already, like are y'all looking to transition to Go or like just kind of mess with it and things like that? Okay. I see some hands. What's up?
I was just curious, when you said that Go only had one vulnerability, do you know how that compares to other languages?
I did take a look. I saw with the Go one, I saw one, but I looked and did a compare with Java, and there were a lot more. And by a lot more, it's like we can actually take a look. But I don't know, my computer might go offline, whatever. But I think the answer to that is like it's probably like tens versus a single one, or in fact like multiples of that versus like a single one. Other questions?
Have you ever found yourself making a particular security mistake or seen a few? Like what kind of weaknesses to watch out for?
I think the trouble is one of the issues that I run into is especially with the HTTP server. You saw like with 10 lines of code, you have your own HTTP server running, but then from a feature perspective, your business people will probably be like, hey, we want to add HTTPS, or we want to make sure that we don't have cross-site scripting and things like that. So you end up like adding these features as you go along. In like languages where you have like large frameworks that you can kind of use immediately, that helps because you can just say, oh, okay, I'll use this module in this like really large framework. But in Go, it's a lot more like leaner and smaller. So I can see like implementing something wrong the first time, and then you're like, oh crap, I didn't mean to do this at all because I didn't know what I was doing, and then kind of going back and like fixing things. And that's why things like Gorilla Mux is really good, and the two other libraries that I talked about, those are really good. The one big thing that that ends up happening is the template, HTML template and text template. If you accidentally remove the import, and if that's the only module like doing all of your templatizing and giving back your HTML, you can cause like a serious issue in there. That's the one probably like big one to kind of watch for. Any other questions?
I think the HTML template to text template is a little gotcha. I know that you can activate it and you can totally accidentally do that.
Yeah, and that one ends up being like probably like pretty common because you might want to show somebody, hey, here's how this FMT module works, and you can like format everything differently, like remove a bunch of stuff, and like on save it adds everything back, or adds everything and like formats things correctly. But if it picks the wrong module, and in the case of basically HTML extends from text. So it picks the base one, which is text, and then ends up foobarring your code. And you might not realize that. You might not realize that when you're like making changes or committing a large bunch of code. So that's a huge one.
What platforms?
Go, I think Go works. I haven't tried Windows, but I know on all it does work on Windows. Okay. On all of Linux, on all of Mac, and Windows as well. So it's pretty much supported everywhere you need to.
I was just goofing off with this the other day, but with 1.5 on my Mac, I could cross-compile to Windows, and I could cross-compile to Linux with no problem. That was kind of stunning to me, so it's fun to mess around.
Yeah, 1.5 definitely makes that a lot easier, because 1.4 you kind of have to do it in a more, like you could still do it, but you had to, it's kind of like cumbersome. But in a single command in 1.5, you can cross-compile to whatever you need to. Typically, what I end up doing for Go templates is I'll end up using Hugo. Hugo is this, I think it's a open source, not wiki, but you can like create websites from it, and it's based entirely on Go. And Steve Francis wrote all that stuff. But whenever I need to have questions about templates or like how do I construct these templating parameters, something like that, I'll end up looking at the Hugo documentation because that's so much better than just regular Go docs for templates. And the problem is that with the Go doc templating, so Go made significant changes like in the 2011, 2012 timeframe. So when you look for code, if you see something in the 2012, like something that's 2011, 2012, you don't want to be looking at that. You want to be looking at like the newer versions of of the packages or of the documentation for the packages. It's just that Google does its job really well. So like the older content is starred better than the newer content, and they're both valid versions, so they both kind of exist together. So that's why you end up like seeing like weird things in templates that don't exist in Go templates 1.5. They might exist earlier on, and you're like, but this doesn't work. That's why I always just look at the Hugo stuff instead. So there've been a lot of like DevOps kind of things that have been written in Go recently. For example, like we use Docker, and Docker is written entirely in Go. I think the HashiCorp uses Go a lot. I think that's their primary language as well. Console's written in Go. Like there's, I think in the last like 3-4 years, a lot of like DevOps tools have been written in Go, and I think it fits really well for like system level stuff where you want things to happen really fast. I didn't even talk about concurrency because you can spend days talking about concurrency, but it's like performance is really good. And for system stuff, you kind of want you end up doing things really fast. So it's really good for that. It's also really good for if you want to do you get a lot of XML or JSON or things like that. You want to do transformations, that kind of stuff. It has like a ton of support for those kind of use cases. So clients that kind of talk to web servers and things like that, a lot of people end up using it in those use cases as well. So. And then web apps as well, because you can kind of write your entire your entire framework from like bottom up. So if you're doing something brand new, it's like a good language to pick for those kind of scenarios. Cool. Anything else? All right. Well, thank you all.